Good morning to one and all. Good morning to one and all. Previous lecture, we are discussing regarding position, displacement, and level type of sensor. Okay. So in that, some of position and displacement sensor we have already discussed. Some of them are left. So we will discuss that. After that, we will discuss level sensor. Okay. In the previous one, we have discussed piezoresistive type of sensor, potentiometric type of displacement sensor, right? So position sensor and displacement sensor are same. Only difference is that the reference point. Okay, in case of position sensor, the reference point it is fixed, and or we are considering one of the reference point in case of position sensor, and it will measure the distance between that object from that reference point. And displacement sensor is nothing but it will measure the distance between position of initial state and position final state. That means this distance is nothing but if this object it is moved from its initial position, then there is a displacement it will be occur. Again, this distance it will measure the distance between its initial point and its final. That means it is displacement, right? So only regardless of that of reference position, both sensors are fabricated or manufactured having a same application. Okay, so this is position and displacement sensor, and we have discussed there are some types in that in that piezoresistive type of position and displacement sensor and potentiometric type of position and displacement sensor. These two types of sensor we have already discussed. Now see, next one type of sensor is that capacitive type of sensor. It is also used to measure the position and displacement. As we know that the value of capacitance or formula of capacitance C is equals to epsilon A divided by D, right? Epsilon A divided by D. That means A is nothing but cross-sectional area of that plate or cross-sectional area of that two cathode and anode plus and minus, and D is nothing but distance between that two plates. Okay, distance between that two plates. That means value of capacitance it is inversely proportional to distance between that two plates. Right? That means it is also used to measure the position or displacement. Displacement is nothing but it is measure the distance. Position it is nothing but again it is the measure the distance. But in case of position sensor, there is one reference point. Okay. Along with that reference point, it will measure the distance. And in case of displacement, its reference point or its initial position, it is nothing but reference point. From its initial position, it will measure the distance. So in that capacitive sensor, after that most important sensor in that LVDT and RVDT. Okay. So that point we will discuss. Again, we are able to use the inductive type of sensor as well as magnetic type of sensor to measure the position and displacement. Okay, so these are the different types of sensor in that capacitive type of sensor. The capacitive displacement sensor, it is having a broad application, or it is used for some of the application, because these are employed directly as a building block in the sensor. Here displacement are the result of force, pressure, temperature and acceleration. In the previous lecture we have discussed one diagram. Okay, in that diagram we are considering input stimulus, or it may be stimulus in the form of pressure. प्रेशरच्या फॉर्म मध्ये स्टिम्युलस कन्सिडर केला होता. ओके, if we are applying pressure by using finger to that flexible spring, it will make the contact. If these are the two plates are like capacitive plate, and if there is a distance between that two plate, it is reduces, it will be measured in the form of capacitance. बरोबर ना? दोन प्लेट ज्या आहेत कॅपॅसिटन्सच्या, फोर्स जर यूज केला एखाद्या फ्लेक्सिबल प्लेटला, या दोन्हीच्या मध्ये डिस्टन्स काय होणार, चेंज होणार. सो इफ फोर्स इट इज वन ऑफ द स्टिम्युलस, if the distance between that two plate, it will be changes, and if the distance changes, that means if there is a capacitive measurement or capacitor measurement device, it can be used. It will measure the capacitor according to equation C is equals to epsilon A divided by D. If the D changes, distance changes, capacitance of that two plates, it will be changes, and if the capacitance of two plate it will be changes, it will be converted into an output voltage form. Okay, so as a result, that means we are using to measure the force, to measure the pressure, to measure the temperature as well as acceleration. So the ability of capacitor, ability of capacitive detector or capacitive sensor, ability of capacitive type of sensor is to sense all virtual, makes them an attractive choice for many of the users. So different types of users are here who are using capacitive type of sensor. So it is used to measure the multiple material distance or some of the stimulus like force, pressure, temperature, acceleration. So here the equation defines, that means the capacitance equation C is equals to epsilon A divided by D. Equation defines the capacitance of that capacitor. It is inversely proportional to distance, right? So C is equals to epsilon A divided by D. That means C is directly proportional to A divided by D. So distance between two plates, it is inversely proportional, or capacitance of the capacitive plate, it is inversely proportional to distance. Okay, inversely proportional to distance between two plates, and it is directly proportional to cross sectional area or overlapping area of the plate. The operating principle of capacitive gauge is based on either changing the geometry, that is a distance between the capacitor plate, or the overlapping area, right? See, if the capacitive sensor is made up of two plates, capacitor construction matter तुम्हाला already it is made up of two plates. So operating principle is कसं operate होईल, C is directly proportional to A divided by D. That means we are able to operate these types of sensor by changing its geometry. Geometry change करून म्हणजे त्याचा shape change करून म्हणू शकतो आपण. Geometry, it is in the form of cross sectional area, or it may be it is in the form of distance between two plates. एक तर distance change करून त्याचा capacitance change होईल, or cross sectional area change करून त्याचा capacitance काय होईल, change. So the operating principle of capacitive sensor or capacitive gauge, it is based on either the changing geometry, that is distance between the capacitor plate or its overlapping area, or variation in the dielectric material. It will be positioned between the two plates. In between two plates, there is a dielectric material or insulating material. It is present in between two plates. Okay. If the distance changes, that means there is a variation of dielectric material. The dielectric heating considered करत असाल, in case of dielectric heating in between two plate आपण त्याच्यामध्ये पालापाचोळा यूज करू शकतो, wood, or it may be that means non-conductive material. Grabs are there, so in between that If the distance between that two plate it will be changed, that means the dielectric material which are used in between two capacitor or two plate, there is a variation in that dielectric, right? There is variation in that dielectric material. When the capacitor changes, if the distance, either distance changes or it may be cross sectional area changes, there is a variation of output capacitance of that capacitive sensor, and these capacitance it can be converted into a variable electric output. हा जो काय कॅपॅसिटन्स आहे त्याचं कन्वर्जन व्हेरिएबल इलेक्ट्रिकल आउटपुट सिग्नल्स मध्ये कन्वर्ट केले जाईल. So by using one of the well-known circuit, okay. So variable electric signal either in the form of voltage or it may be current. So change in voltage change output la occur with the sensor because of distance or it may be because of cross sectional area. Okay. As it is used for many of the sensor, capacitive sensor can be either monopolar or it may be it is a differential type of capacitor. That means monopolar it is nothing but it is just only one capacitive type of sensor is used in that system, or it may be two capacitor it can be used in that system. So if again we are able to using the four capacitor, if the four capacitor it will be used, so there is a bridge formation it will be. मतलब measure of the measurement मतलब capacitance measurement साठी मतलब unknown capacitor measurement साठी this out bridge बरोबर आहे. Kelvin double bridge to measure the capacitance. बोलते हैं शेयरिंग ब्रिज है ना, sharing bridge आएगा. For inductance measurement there is a Maxwell inductance bridge. For unknown capacitance measurement there is a sharing bridge. बघा measurement मध्ये आहे की sharing bridge चे. So if we are using four capacitor, जर four capacitor use केले, it will forms as a one bridge. When two or four capacitor it can be used, जर दोन वा चार capacitor use केले, if we are using two capacitor, okay, that means if we are using differential type of sensor, monopolar only one capacitor is there, जे तेवढाच unknown असेल. Okay, if two capacitor we are using, that means in that two capacitor one capacitor is fixed. एक काय असेल fixed असेल and one is unknown. So by varying that distance, it will show its value according to equation C directly proportional to PA divided by T. So and when four capacitor it can be used, in that four capacitor, two capacitors it may be either fixed or variable and changing it will by opposite phase. जर चार असतील त्याच्यामध्ये दोन कॅपॅसिटर फिक्स्ड असतील or maybe two capacitor are variable. So this is just formation of sensor, whether we are using only one type of capacitive sensor, we are using only two capacitive sensor, or it may be four capacitor. If four use, then there is a bridge it will be formed. Okay, and depending upon bridge balance condition, we are finding the unknown value of capacitor. After that, again the inductive and magnetic type of sensor it is also used to measurement of position and displacement. So in that the advantages of magnetic field in the sensing position as well as distance is that many non-magnetic material can be penetrated by the field with no loss of position accuracy. If we are using magnetic or it may be inductive type of capacitor, these types of capacitor can be used when the non-magnetic material we want to penetrate in file with no loss of position. What is the meaning of that sentence? इंडक्टिव्ह और मॅग्नेटिक टाइप ऑफ सेन्सर जे आहे आपल्याला पोझिशन मेजर करायचे किंवा ॲक्युरेट पोझिशनला एखाद्या कंट्रोलिंग फंक्शन साठी यूज करायचे. सपोज वी वांट टू पेनिट्रेट एनी वन ऑफ द नॉन मॅग्नेटिक मटेरियल. एखादं नॉन मॅग्नेटिक मटेरियल काय करायचे म्हणजे एक खिळा या वूड मध्ये काय करायचं पेनिट्रेट करायचं. बरोबर. सो जर कॉम्प्लेक्स सर्किट असेल किंवा कॉम्प्लेक्स एखादा काय म्हणतो कॉम्प्लेक्स डिव्हाइस असेल त्याच्यामध्ये आपल्याला स्क्रू टाईट करायचं आहे. ओके. सो दिस मॅग्नेटिक मटेरियल वी वांट टू पेनिट्रेट ऑन इट इज वूड. इट इज नॉन मॅग्नेटिक. Without loss of position or without loss of position accuracy, we are able to do that function by using magnetic and inductive type of sensor. So this is the advantages of that magnetic and inductive type of sensor. Stainless steel, aluminum, brass, copper, plastic, masonry and wood can be penetrated, meaning that accurate position with respect to the probe at the opposite side of the wall can be determined nearly instantly. Okay. See, stainless steel material, aluminum material, wood material, copper material, जे काय material असेल either it may be magnetic or it may be non-magnetic, and we want to penetrate at accurate position by using these types of sensor. So in that, without losing its accuracy or without losing its position, we are able to penetrate on the opposite side of the wall. Opposite side of the wall can be determined nearly instantly. म्हणजे एखादी वॉल आहे त्याच्यामध्ये पेनिट्रेट करायचंय, इकडून एक स्क्रू काय करायचंय पलीकडे पेनिट्रेट करायचंय. ओके. सो without losing its position, we are able to penetrate by using magnetic and inductive type of sensor. Okay, inductive and magnetic type of sensor. So this is also one of the advantages of these types of sensor. And last one advantages is that the magnetic sensor can work in the environment, that is severe environment, as well as that is severe environment is nothing but dirt or it may be dust position. Okay. Dirty environment, dust position, corrosive situation, it is able to use the corrosive situation because the probe and target can be coated with inert material that will not adversely affect the magnetic field. याच्यामध्ये सेन्सर मध्ये जो काही प्रोब यूज केलेला आहे and our target is nothing but accurate position. So these 2 points are coated with inert material, inert gas material, and because of that there is a no effect on the magnetic field. Magnetic field वरती काही इफेक्ट होणार नाही. So this is the some of the advantages of inductive and magnetic type of sensor. Then this is next one type of sensor, that is LVDT and RVDT. LVDT, linear variable differential transducer, that is sensor, or RVDT is nothing but rotary variable differential transducer. LVDT and RVDT. So these are the two types of sensor, again used to measure the position and displacement. So these types of sensor or working principle of these types of sensor, it is same like as that of electromagnetic induction. जे काही इलेक्ट्रोमॅग्नेटिक इंडक्शन प्रिन्सिपल आहे त्याच्यावरती LVDT and RVDT काय करत वर्क. ओके. LVDT is nothing but linear displacement. It is used to measure the linear displacement. RVDT, its name suggests that rotary variable differential transducer, that means it is used to rotary function to measure the distance, circular distance, or it may be rotary displacement. Okay. So LVDT, to detect the position and displacement, it may be sensed by the method of electromagnetic induction. Its principle it depends upon electromagnetic induction principle. Magnetic flux coupling between two coils. It can be altered by the movement of object and subsequently converted into voltage. So, what is electromagnetic induction principle? By electromagnetic induction principle. What is the electromagnetic induction principle? Faraday's law of electromagnetic induction क्या है? क्या है? Faraday's law. Whenever there is a change in magnetic field or when a conductor cuts the magnetic lines of force, then there is a some EMF it should be induces in that signal. So that means on that similar principle, if we are taking two coils or we are taking two poles, N pole and S pole, either it may be these two poles are permanent magnet or it may be electromagnet, right? If the permanent magnet is the electromagnet. So if we are considering these are the two permanent magnet, the flux lines are passing from N pole to S pole, or always there is a flux it will be present in between that. And if any one of the conductor or any one of the we can call it as here rotor, the rotor काय केला त्याच्यामध्ये प्लेस केला in between magnetic field. When EMF it will be induces, कधी EMF induce होतो? When the rotor rotates, बरोबर ना? That means त्याची पोझिशन काय झाली चेंज झाली either circular form मध्ये किंवा linear form, बरोबर? Then there is a EMF which will be induces. On the same principle, the LVDT it will be what? A magnetic flux it will be coupling between two coils. It is altered. Meaning of altered is nothing but change. Magnetic field का होता change होता when the movement of object. त्याच्यामध्ये जो काय object आहे in between that two coil किंवा in between that field, if we are placing any one of the object, if the movement of that object, the magnetic field or flux lines cutting and it will be converted into an induced EMF, subsequently converted into a voltage. That means induced EMF. So variable inductance sensor that uses a non-magnetic ferromagnetic medium to alter the reluctance. Okay. So अपन flux change करतोय किंवा flux change cut करतोय. So meaning of that its reluctance it will be changes. माहिती आहे simple loop generator चं working principle. जनरेटर वर्किंग प्रिन्सिपल माहिती असेल सिंपल लूप जनरेटरचा कशी एसी वेव्हफॉर्म फॉर्म मध्ये माहिती आहे ना any one of the coil it can be considered in between magnetic field च्या मध्ये having an N4 and S4 flux lines are passing from N to S and we are considering one coil बरोबर एक कॉइल कन्सिडर करतो याची मूवमेंट झाली ही रोटेशनल मोशन आहे याची मूवमेंट झाली म्हणजे आपण याला इनपुट कनेक्ट करतोय बाय युजिंग प्राइम मूव्हर बरोबर प्राइम मूव्हरचा यूज करून आपण काय करतो याला इनपुट दिले की ते काय होईल रोटेट होईल at that situation when the edge AB it is at zero position तर त्यावेळेस 0 पोझिशन ला असेल at that situation flux linkage to the coil side AB it is maximum but the rate of change of flux cutting is minimum and rate of change of flux cutting is minimum according to Faraday's second law is directly proportional to d phi by dt. d phi by dt is nothing but rate of change of flux cutting. If the rate of change of flux cutting it is minimum, so that means induced EMF or output voltage obtained it is also minimum. So that initial position coil ज्यावेळेस initial position ला असेल at that situation induced EMF it is low or it may be near about source. Now coil start rotating because we are providing prime mover provide केलेलं आहे so coil काय होते rotate होते if the coil rotating and it will be shift some angle. When the coil it will be start rotating, at that situation flux linkage to the coil start reducing and rate of flux cutting it is start increasing. And if the rate of change of flux cutting it is increasing, the induced EMF it will be start increasing. And at the position 90 degree position, ज्यावेळेस ही coil AB side आहे 90 degree ला येईल. At that situation, flux linkage to the coil is minimum, but the rate of change of flux cutting is maximum. Rate of change of flux cutting is maximum, that means induced EMF it will be maximum. Induced EMF का होतो maximum होतो at 90 degree position. After that, when coil rotating from 90 degree to 180 degree, again reverse it will be happen. That means flux linkage to the coil it will be start increasing and rate of change of flux cutting it will be start decreasing. And rate of change of flux cutting decrease झालं म्हणजे induced EMF काय होतं decrease. And again at 180 degree it will obtain zero EMF or it may be zero. And after that, after 180 degree, same procedure, but it is reverse direction. So that we are calling it at the output obtained from the DC generator, it is in the form of AC voltage. So that we are using after that commutator to convert that AC to DC. Cycle कशी obtain होते, this is explained by using simple loop generator. So similarly, this principle it can be used in case of LVDT and RVDT. So in that the variable inductor sensor that uses a non-magnetic ferromagnetic medium to alter the reluctance of the flux path, and so it is called as variable reluctance type of transducer. The एखादं ferromagnetic material, if it is in between these two magnetic field, in between that two pole, so if ferromagnetic material it will be used, it will changes the reluctance of that medium's reluctance change will, so that this types of transducer or this types of sensor it is called as variable reluctance type of transducer. The reluctance type of transducer असते. So LVDT. Okay. See, the basic arrangement of LVDT is that similarly working principle of DC generator. These are the coils. There are requirement of two coil. One is called as primary, another one is called as secondary. So in between that one of the object, एक object का place केले. Okay. So the movement of that object it will be upon. That means this is the linear movement only. बार एक consider केले. There is a linear movement of that object. If the linear movement of that object it will be occur, there is a change in flux or change in induced EMF. If the flux change, that means induced EMF or voltage of obtained it will be changes. Here it is V reference. एक V reference म्हणजे आपण input voltage देणार. Because of that input voltage, there is a induced EMF. It will be occur in the secondary side. Secondary side la EMF induced is if its displacement or this bar it get displacement. अजून काय bar आहे? If its displacement it will be occur its linear displacement either in the forward direction or it may be backward direction. Because of that its flux it will be altered or it may be flux changes, and if the flux it get altered its output voltage it will also change. So this is LVDT. The basic arrangement of multi-induction transducer. It will contain at least two coil, that is primary and secondary coil. So the primary one carries the excitation voltage or it may be reference voltage, supply voltage, and that induces the secondary side AC voltage in the secondary side. Okay. Similarly, किंवा याला आपण इलेक्ट्रोमॅग्नेटिक इंडक्शन, म्युच्युअल इंडक्शनचा प्रिन्सिपल म्हटलं तरी काय अर्थ, बरोबर? प्रायमरी आणि सेकंडरी किंवा ट्रान्सफॉर्मरचं सेम प्रिन्सिपल आहे. There is also EMF induction in the secondary side. Okay. So the induced amplitude किंवा जे काही induce होणारा voltage आहे at the side of secondary, it will be depends upon flux coupling between the coil. Okay. हा जो काही induce होणारा EMF आहे कशावरती डिपेंड आहे? E is directly proportional to d phi by dt, that means it depends upon flux. आता flux किती alter होतोय because of this object, there is a flux alteration it will be occur or flux change it will be occur. If the flux change, it will be occur. So if the flux altered, then induced EMF it is also altered. So this is the simple arrangement of LVDT. LVDT, why it is called as linear variable? That means the object it is varying linear. एकदम तो forward मध्ये move होतोय किंवा backward मध्ये. So that means linear displacement. You can call it as a linear displacement. Rotary असेल तर या दोन्हीच्या कॉइलच्या मध्ये काय असेल? Rotary object असेल. So rotary object and linear object. What is the movement of the object made of a ferromagnetic material with the flux path? This change, बघा तो जो काय ऑब्जेक्ट आहे in between that two coil ला सप्लाय दिल्यामुळे काहीतरी फ्लक्स प्रोड्यूस होतील. This flux it will be linked to the secondary coil, and in between that two there is a ferromagnetic material it can be used. If the linear displacement of that material it will be occur, because of that the reluctance of that path it will be changes. दोन कॉइलच्या मध्ये जो काय पाथ आहे त्याचा रिलक्टन्स चेंज होईल. फेरोमॅग्नेटिक मटेरियल म्हणजे कोणतं मटेरियल? मॅग्नेटिक मटेरियल का नॉन मॅग्नेटिक मटेरियल? So due to that the flux path reluctance it will be changes, and if the reluctance it will be changes, the flux obtained at the secondary side it will be changes. Secondary side ला जे काय obtain होणारा फ्लक्स आहे ते चेंज होईल. बरोबर? If the secondary flux it will be changes, secondary induced EMF it will be changes. Secondary side ला induce होणारा EMF काय होईल? Change. So this change the reluctance of the path, which in turn alter the coupling between the coil, and this is the basis of operation of LVDT. त्याची मूवमेंट झाली linear movement ferromagnetic material ची. Reluctance change will, if the reluctance changes, that means secondary side का obtain होणारे जे काही flux है it will be changes. If the flux linkage to the secondary side it will be changes, the induced EMF at the secondary side it will be changes. Okay, induced EMF का will change होईल. So it is the basic operation or function of LVDT, that is linear variable differential transformer, and RVDT is nothing but rotary variable differential transformer. You can call it as a transducer also, is nothing but sensor. And the mutual inductance proximity type of sensor. The proximity type of sensor, again same transformer principle in that mutual induction principle. The other method is to physically move one coil with respect to another. If another method is the same construction, instead of doing movement of that ferromagnetic material, त्याला आपण कोर पण म्हणू शकतो. बरोबर? Instead of त्याची कोरची मूवमेंट किंवा in between that जे काही मटेरियल आहे त्याची मूवमेंट होण्यापेक्षा आपण कॉइलची मूवमेंट केली. लक्ष देते का? If the movement of coil it will be occur. If the movement of coil it will be occur, that means again flux linkage to the secondary side it will be changes. बरोबर? Flux linkage to the secondary side it will be changes, and if the flux linkage to the secondary side it will be changes, that means induced EMF at the secondary side it is changes. Secondary side la induce honara EMF काय will change will. So this is another method to measure the displacement. आता displacement measure करायचे म्हणजे ज्याची displacement measure करायचे एखाद्या इक्विपमेंटची किंवा एका पर्टिक्युलर डिस्प्लेसमेंट पर्यंत त्याला डिस्प्लेस करायचं किंवा मूव करायचं. At that situation, this any one of the coil it will be act as a that object or it may be material. जे का ऑब्जेक्ट असेल ती एक कॉइल म्हणून ऍक्ट होईल आणि त्याची मूवमेंट झाली कॉइलची मूवमेंट डिपेंड्स अपॉन कॉइल मूवमेंट the output it will be changes. So this is another method to change the movement of coil. Another method to change the movement of coil. Consider LVDT as a transformer with a mechanically actuated core. This is same as that of transformer having a two coil, and in between that there is a core or it may be ferromagnetic material. The primary coil is given by a sine wave excitation signal having a stabilized amplitude. So primary coil आपण त्याला V reference देतोय म्हणजे excitation देतोय. So this is a sine wave excitation or it may be AC excitation. It can be given to the primary coil. if the moment of object, or it may be if the moment of that ferromagnetic material which are placed in between that two coils, it will be happen. Then again there is alteration of flux. If the alteration of flux, that means there is alteration of voltage. If we are moving manually the coil, any one of the coil manually move daily, again there is alteration of flux in the secondary side. If there is alteration of flux in the secondary side, again there is a variable induced voltage, it will be of, variable induced voltage, it will be of the. So this LVDT, we are giving AC supply instead of primary, so AC signal it is given to the primary side, and because of AC signal or AC voltage it can be applied to the primary side, it will induces some of the EMF with the secondary side, right? तो काय करेल, काहीतरी EMF induce होईल when there is a no movement, काही movement नसताना तो काय करत असेल, EMF induce करेल. If the movement it will be occur, जर movement occur झाली, जो काही induce होणारा EMF काय आहे, चेंज होणार, बरोबर. induce होणारा EMF चेंज होईल because flux जे काही सेकंडरी साइडला लिंक होणार आहे ते चेंज होईल. Okay, so AC signal it will be induced in the secondary coil. A core made up of ferromagnetic material is inserted coaxially into the cylindrical openings without physically touching to the coil. जे काय कोर आहे किंवा फेरोमॅग्नेटिक मटेरियल जो ऑब्जेक्ट कन्सिडर केलेला आहे, इफ वी आर कन्सिडरिंग लिनियर और एलव्हीडीटी, लिनियर मूवमेंट कन्सिडर करत असेल, so this core it will be placed in between that two coil, and there are two secondary are shown, दोन secondary side आहे, दोन secondary side आपण कनेक्ट केले. I think you people know the which connection, zigzag connection. Have you know zigzag connection? How many coils are there? Zigzag connection. Zigzag star किंवा zigzag delta किती कॉइल्स असतात? 3. प्राइमरी साइडला किती असतात? प्राइमरी साइडला 3, सेकंडरी साइडला 3. डिफेन्स सांगते का? डिफेन्स zigzag कनेक्शन कसं असतं? किती कॉइल्स असतात? प्राइमरी साइडला किती कॉइल्स असतात? 3. सेकंडरी साइडला 3. ते zigzag कसं होईल? ते कनेक्ट केलं तर स्टार मध्ये होईल, डेल्टा मध्ये होईल, किंवा डेल्टा स्टार करू शकतो, स्टार डेल्टा करू शकतो, डेल्टा डेल्टा करू शकतो. तर zigzag का मध्ये झालं ना, झालं ना zigzag कनेक्शन. किती कॉइल्स असतात? 6. किती असतात? ते zigzagचं वेव्हफॉर्म, याची वेव्हफॉर्म माहिती आहे तुम्हाला? zigzagची वेव्हफॉर्म अशी ते अशी काहीतरी येते स्टारची असतात, बरोबर. माहित नाही किती कॉइल्स असतात? कॉइल किती असतात सांगा मला? 20 ना 3. म्हणजे प्रत्येक फेज मध्ये एक कॉइल आर वाय बी, प्रायमरी साइड, सेकंडरी साइडला आर वाय बी, इकडे 3 आणि इकडे 3 चा zigzag कनेक्शन फॉर्म करतो आपण. See, in zigzag connection, each phase, on the secondary side of each phase there are 2 coils. सेकंडरी साइडच्या प्रत्येक फेज मध्ये काय असतात two coils having a same number of turns सेम नंबर ऑफ टर्नच्या दोन कॉइल्स असतात सेकंडरी साइडला प्रायमरी साइडला इनपुट दिले की सेकंडरी साइडला ईएमएफ इंड्यूस होईल सेम नंबर ऑफ टर्न्स आहे it is placed in the common core so that induced EMF in the these two coils also same the zigzag कधी होतं कसं कनेक्शन केलं तर zigzag होतं कसं कनेक्शन करतो मोबाईलवरती बघताय का कसं कनेक्शन करतात zigzag connection see बस से आशा ठीक है so this will form a one groove this will form another one groove zigzag connection very possible है this is possible when on the secondary side of the transformer if there are two coils in each phase are present then the zigzag connection is possible जर ट्रान्सफॉर्मरच्या सेकंडरी साइडला दोन कॉइल प्रेजेंट असतील इन ईच फेज तर झिगझॅग कनेक्शन पॉसिबल नाहीतर ते झिगझॅग कनेक्शन नाही आपण त्याला स्टार डेल्टा कनेक्शन म्हणतो स्टार झिगझॅग किंवा डेल्टा झिगझॅग म्हणू शकतो सेकंडरी साइडला काय पाहिजे दोन कॉइल पाहिजे इन ईच फेज मध्ये हॅविंग अ सेम नंबर ऑफ टर्न्स कसं कनेक्शन करायचं मग इथं कनेक्ट केलं याचं काय मीनिंग झालं डायरेक्ट इथं कनेक्ट केलं तर या दोन कॉइल सिरीज मध्ये झाल्या मग ही डिवाइड करण्यापेक्षा याच्यामध्ये जर केली असते चालू मध्ये झिगझॅग कनेक्शन फॉर्म होईल का नाही हे झिगझॅग कनेक्शन नाही याचे कनेक्शन असं असतं इन ग्रुप 1 ऑफ वन फेज इट कॅन बी कनेक्टेड इन ग्रुप 2 अदर दॅन दॅट फेज या ग्रुप 1 मधली जी काही कॉइल असेल एका फेजची ती दुसऱ्या ग्रुपच्या कॉइलला कनेक्ट करायची अदर दॅन दॅट फेज म्हणजे ही फेज सोडून ही कोणती फेज आहे आर फेज आहे ही आर फेजच आहे याला आपण जर आर डॅश आर डबल डॅश कन्सिडर केलं ही फेज सोडून दुसऱ्या कुठल्याही फेजला कनेक्शन केलं इट विल फॉर्म अ झिगझॅग कनेक्शन म्हणजे सपोज स्टार असेल हे पॉइंट कॉमन आहे याचं कनेक्शन इथं केलं याचं कनेक्शन इथं केलं आणि याचं कनेक्शन इथं केलं आणि तीन टर्मिनल जे असतील त्या इट विल फॉर्म अ झिगझॅग कनेक्शन इफ group 1 coil of one phase it can be connected to the group second other than that phase to other than same r phase सोडून दुसऱ्या phase ला कनेक्ट केले त्याचं zigzag connection form that means on the secondary side there are two coils here there are two coils are there secondary side ला दोन coils आहेत secondary are connected and these two coils are connected in opposite phase the दोन opposite phase मध्ये कनेक्ट केले so meaning of that opposite phase मध्ये कनेक्ट केले आउटपुट व्होल्टेज ऑक्टेन किती असेल opposite phase मध्ये दोन कॉइल कनेक्ट केले असल्यानंतर डॉट दिलेले होते बघा कनेक्शन बघा सेकंडरी साइड ची एक कॉइल आहे and this is another one coil आणि याचं इथे डॉट दिले काय असते मीनिंग डॉटचे कोणती पोलॅरिटी okay these are connected to opposite polarity dots meaning dot if we are considering either positive or negative but it depends upon its current direction म्हणजे याचा जो काय म्युच्युअल इंड्यूस्ड ईएमएफ किंवा म्युच्युअल इंडक्टन्स किंवा व्होल्टेज असेल ते कसं पॉझिटिव्ह आहे का निगेटिव्ह आहे हे डॉट वरती डिपेंड राहील बरोबर सो इफ बघा सांगतो 2 मिनिटात इफ current enter in the first coil from dotted end also current enter in the second coil from the dotted end दोन्ही कॉइल मध्ये एंटर होणारा करंट जर डॉटेड एंड कडून एंटर होत असेल किंवा डॉटेड एंड कडून लीव होत असेल, then there is a additive polarity of induced EMF. additive polarity म्हणजे दोन्हीचे इंड्यूस होणारे EMF काय आहे, ऍड होतील. if current enter in the one coil from dotted end and current leaves from second coil from dotted end, then there is a subtractive polarity. suppose current याचा इकडून एंटर होतोय, पहिल्या कॉइल मधून डॉट पहिल्या साइड वरून एंटर होतोय का लीव होतोय, म्हणजे डॉट पहिल्या साइड वरून लीव होतोय. सेकंड कॉइल मध्ये डॉट पहिल्या साइड कडे एंटर होतोय का लीव होतोय, एंटर होतोय. whether it is opposite polarity or whether it is subtractive polarity or additive polarity, subtractive polarity. getting काय झाली, सबस्ट्रॅक्टिव्ह जर डॉट कडून एंटर होत असतील, हा जर डॉट इथं असता तर इथं या कॉइल मधून लीव होणारा करंट हा डॉटेड एंड कडून आहे, या कॉइल मधून लीव होणारा करंट पण काय आहे, डॉटेड एंड कडून आहे. सो देयर इज ऍडिटिव्ह पोलॅरिटी. काय झाली, ऍडिटिव्ह पोलॅरिटी म्हणजे इंड्यूस्ड EMF इन द फर्स्ट कॉइल and the induced EMF in the secondary coil are adds each other. Okay, see these two coils secondary side च्या coil ज्या आहेत, these are connected in opposite polarity having a same number of turns. same number of turns आहे, opposite polarity आहे. So at the normal condition if we are giving AC supply ज्यावेळेस आपण दिलेला आहे प्रायमरीला, सेकंडरी साइडला EMF इंड्यूस होतोय, दोन्हीच्या नंबर ऑफ टर्न्स सेम आहे, आउटपुट व्होल्टेज किती असेल, आउटपुट व्होल्टेज म्हणजे या इथलं व्होल्टेज, याचे डिस्कशन झालं. डॉट इथं आहे त्याचा डायग्राम मध्ये बघितलं असेल ना, एक्झॅक्ट नोट. अपोजिट पोलॅरिटी म्हटलेलं आहे, ज्यावेळेस इथला ऑब्जेक्ट जो आहे फेरोमॅग्नेटिक मटेरियल त्याची मूवमेंट नाहीये, हा इंड्यूस करतोय V1, हा इंड्यूस करतोय V2, बरोबर. याचा EMF इंडक्शन V1 आहे, याचा EMF इंडक्शन V2 आहे, आणि इथं जे आउटपुटला दाखवलेलं आहे या दोन्हीच असेल, either additive or it may be subtractive. So this ferromagnetic material at this position इथं आहे, आणि इंड्यूस प्रायमरी साइडला काय केलेलं आहे, आपण व्होल्टेज दिलेलं आहे, बरोबर. प्रायमरी साइडला व्होल्टेज दिलेलं आहे. if we are giving AC supply to the primary side, it will induce some of the EMF in the secondary, or some flux it will be linked to the secondary when there is a no movement either in the forward direction or it may be backward direction. backward direction ला किंवा forward direction ला काही नाही, याची movement नाही, बरोबर. if there is a no movement, if it is kept centrally, प्रॅक्टिकल मध्ये आहे बघा, हे आपल्याला हा काय सेंट्रली प्लेस केलेला आहे, movement नाही याची, at that situation आउटपुटला व्होल्टेज किती असेल, असं मला क्वेश्चन. या दोन नंबर ऑफ टर्न्स सेम आहेत, या दोन नंबर ऑफ टर्न्स सेम आहेत. somewhat voltage it can be applied to the primary side, it will induce some of the EMF in the primary as well as secondary. output voltage किती असेल, काही कळलं नाही. याची मूवमेंट आहे का, जे काही फ्लक्स लिंक होणार आहे या कॉइलला पण तेवढेच, या कॉइलला पण तेवढेच, बरोबर. या कॉइलला लिंक होणारे फ्लक्स समथिंग आहे, या कॉइलला लिंक होणारे फ्लक्स समथिंग आहे, याच्यापासून इंड्यूस होणारा EMF सेम फ्लक्स असल्यामुळे हा सेम असेल, हा सेम असेल. इट इज कनेक्टेड इन अपोजिट पोलॅरिटी, दोन्हीचा डिफरन्स इज नथिंग बट आउटपुट व्होल्टेज इज 0. आउटपुट व्होल्टेज किती असेल, 0 असेल. नाउ इफ this ferromagnetic material or object it will be move in this direction, त्या डायरेक्शन ला मूव जात, बरोबर. आता सिच्युएशन what will happen, flux linkage to the point 2 it will be changes. त्याची मूवमेंट इकडे झाली, हे काय करतं, याचा रिलक्टन्स चेंज करते, म्हणजे पाथ मधून जाणारे जे काही फ्लक्स आहे रिलक्टन्स चेंज करते, म्हणजे इकडे रिलक्टन्स इन्क्रीज होईल, रिलक्टन्स इन्क्रीज झाला, फ्लक्स लिंक होणारे चेंज होतील, vary होतील. flux linkage it will be changes, the plus linkage it will be changes, that means induced EMF at this coil it will be changes, either reduce होती है or increase होती है, depends upon direction. So हे जर reduce झाले या दोन्हीचा डिफरन्स, because it is connected in opposite, it will show some of the voltage. ते काय करेल, काहीतरी voltage show करेल, that means there is a movement of that object, or this object it will be displaced. This LVDT type of transducer or LVDT type of sensor, it is used to represent the direction also, or it will be shows the direction. त्याच्यावर आपण त्याची डायरेक्शन पण अंडरस्टँड करतो की त्याची डिस्प्लेसमेंट फॉरवर्ड डायरेक्शन न झाली का बॅकवर्ड डायरेक्शन. लक्षात येते बरोबर. जर या डायरेक्शन न डायरेक्शन म्हटलं आपण V1 V2 घेत असो तर आपल्याला आउटपुट व्होल्टेज जर पॉझिटिव्ह दाखवलं, आउटपुट व्होल्टेज पॉझिटिव्ह शो केलं, आपण म्हणणार फॉरवर्ड डायरेक्शन न काय त्याची मूवमेंट झाली. किती मूवमेंट झाली हे पण दाखवेल, because of it will show some of the flux, its reference voltage is 0. Now it will be move in this backward direction, backward direction ना मूव झालेला आहे. याचा रिलक्टन्स चेंज होईल, म्हणजे याच्यापासून इकडे जाणारे फ्लक्स काय होतील, चेंज होतील. if the flux it will be changes, or लिंक होणारे फ्लक्स जे सेकंडरी साइडला it will be changes, then induced EMF at this point it will be changes. EMF induced होणारा चेंज होईल. Again equation V1 V2, जी काय व्हॅल्यू येईल ती मायनस व्हॅल्यू असेल, that means we can say that this displacement of that object in the backward direction. जी काय ऑब्जेक्ट ची डिस्प्लेसमेंट आहे ती बॅकवर्ड डायरेक्शन आहे. See here it is given, when the core is positioned in the magnetic center, जर core magnetic center ला असेल of the transformer, the secondary output signal cancel and there is a no output voltage. बरोबर. जर सेंटरला असेल, हा सेंटरला आहे, लिंक होणारे जे काय फ्लक्स आहेत दोन्ही मध्ये सेम असतील, because these two are having a same number of turns, same number of turns आहेत, लिंक होणारे फ्लक्स पण सेम आहेत. according to equation E is directly proportional to, E is equals to n d phi by dt. n सेम आहे, लिंक होणारे फ्लक्स सेम आहे, that means induced EMF काय आहे, सेम आहे. सपोज याच्यामध्ये इंड्यूस होणारा EMF 10 आहे, याच्यामध्ये इंड्यूस होणारा EMF 10 आहे. बरोबर. These are connected in opposite polarity so that output voltage obtained at the output side it is positive. ठीक है, voltage असेल ते काय असेल, so there is a no output voltage, right? So moving the core away from the central position, आता ते काय core किंवा ऑब्जेक्ट जे आहे त्या सेंट्रल पोझिशन पासून मूव्ह केलं, either in the forward direction or maybe backward direction, जे आता मी प्रोसिजर सांगितली सेम. So core away from the central position, it will unbalance the induced magnetic flux ratio between the secondaries and it will develop out. Okay, तो रेशियो चेंज होईल V1 आणि V2 चा, आणि त्याच्यामुळे काहीतरी आउटपुट व्होल्टेज काय it will show करेल. So as the core moves, the reluctance of the flux path it will be changes. Core moves झाला forward direction ना flux path चा reluctance काय होईल, change होईल, induce होणारा EMF पण काय होईल, change. Hence the degree of flux coupling between it will be depends upon axial position of the core, the core चा किंवा ऑब्जेक्ट च्या axial position वर डिपेंड आहे. At a steady state, the amplitude of the induced voltage, at a steady state amplitude of the induced voltage, it is proportional to the linear operating region and its core displacement. The core चा displacement वरती operating depends असेल. Consequently, voltage may be used as a measure of displacement. जे व्होल्टेज आउटपुटला मिळणार आहे ते शो करेल आपल्याला किती डिस्प्लेसमेंट आहे. पॉझिटिव्ह असेल या डायरेक्शनला एवढी डिस्प्लेसमेंट झाले, इट विल बी डिपेंड्स अपॉन मॅग्निट्यूड ऑफ व्होल्टेज, व्होल्टेजच्या मॅग्निट्यूड वरती डिपेंड आहे. and the LVDT provide the direction as well as magnitude of displacement. Okay, आता जे काही मी सांगितलं, it will provide direction also as well as it will provide magnitude also. And the direction is determined by the phase angle between the primary and secondary voltage. Excitation is generated by the stable associator. ही जी काही डायरेक्शन आहे त्याच्यावरती डिपेंड राहील मॅग्निट्यूड and its output obtained from that two coil, दोन coil ला जे काय आउटपुट शो करेल त्याच्यावरती डिपेंड. Okay, so this is related to LVDT. Similarly, if we are changing that ferromagnetic material or object in the form of rotary, this types of transducer or sensor, it is called as RVD. Hello, RVD. Okay, so similar function of RVD2. Okay, so in this way we will conclude this student lecture. Is there any doubt? Hmm? प्राणायाम है ना?